Hello everyone, and welcome to the first Matplotlib lecture. In this lecture, we're going to begin to show you how you can use Matplotlib with Python. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here I am at the notebook. The notebook for this lecture is called Matplotlib Concepts Lecture. And all the code I'm going to be doing is located in this notebook, as well as a lot more information that's available to you regarding Matplotlib. Okay, I'm going to go ahead and jump to a blank notebook and walk through all this code and explain it for you. Let me go ahead and click this new tab, and here I have this new notebook. I'm going to go ahead and hide the header and toolbar just to get a little more room here. Okay, let's go ahead and get started with Matplotlib. Once you've installed Matplotlib, the first thing you're going to be able to do is say import matplotlib.pyplot as plt. And then, if you're using the Jupyter Notebook, what you're going to have to do is say $matplotlib space inline. And that's going to allow you to actually see the plots you create inside the Jupyter Notebook. Let's go ahead and run this. Great. If you are not using the Jupyter Notebook system, what you're going to go ahead and do is at the end of all your commands for plotting, which we'll show later, what you will type is plt.show close parentheses. And later on, when we actually start plotting some examples, I'll show you where to actually put that into your code. Alright, let's go ahead and walk through a very simple example using two NumPy arrays. I'm going to go ahead and say import NumPy as NP, and say x is equal to NP linspace. So it's going to be linearly spaced. We'll go from 0 to 5 and grab 11 points. And then y is going to be equal to x to the power of 2. So if we take a look at x and y, we have an array from 0 to 5, and then y are just all those elements squared. Now, basic Matplotlib commands allow you to very quickly create a plot, and we'll show you two ways of creating Matplotlib plots. One is a functional method, and the other one is the object-oriented method. We'll show you the functional method first, and then we'll shift over to the object-oriented method, since that's usually the better way of creating a Matplotlib plot. Let's go ahead and show you the functional method first. The functional method is actually quite simple. You say plt.plot, and then we can do shift tab here, and you're going to pass in several arguments. First one you're going to do for just a basic plot is pass in your x and your y elements, and then we can go ahead and do shift enter. And here, this will actually show the plot. We've went ahead and plotted x versus y. If you're not in the Jupyter Notebook, which you are going to do at the end of this line, before you run your code, is say plt show. And then if I run that, we can see we get the same plot. You don't have to use plt show unless you're using something that's not the Jupyter Notebook. The difference in the Jupyter Notebook is essentially like you're printing the plot. Notice here, if I don't have plt.show, I get an out cell. If I remove this, or actually put it back in, then I don't get the out cell. That's essentially the same thing, just to do a quick analogy, as typing a string versus saying print the string. And that's the exact same thing what plt.show is doing. It's essentially printing out this plot instead of just showing the plot. Alright. For now on, we won't actually concern ourselves with consistently typing plt.show. However, if you're not using Jupyter Notebook, you will have to keep typing that. So just keep that in mind. Alright, so that's the most basic way to plot something in Matplotlib, which isn't so bad. You can actually add MATLAB-like arguments, such as color and line style, and that will allow you to continue to edit this plot. We'll talk a lot more about this later on as far as line styles and color styles, but if you're familiar with MATLAB, this probably already seems familiar to you. Let's go ahead and remove that for now and just go with the basics. If we want to add an X label, Y label, or a title to this plot, we can do that with the following methods. We can say plt X label, and then just pass in a string you want for the X label. We'll go ahead and say X label, and then for the Y label, you can say plt.ylabel, pass in a string Y label, and then for the title, you can say plt.title, and then we'll just go ahead and put in a title string there. Let's go ahead and run this, and now we can see we have an X label, a Y label, and a title. And later on, we're going to learn how we can specify the DPI, or dots per inch, in order to get some more clarity here, such as a finer font. Let's go ahead and continue on with creating multi-plots on the same canvas. I'm going to go ahead and scroll down here, remove this cell, and talk about putting multi-plots on the same canvas. In order to do that, we're going to say pt.subplot. And subplot takes in a couple arguments as well. Right now we can't see them, so I'll go ahead and tell you. The first one is going to be the number of rows, the number of columns, and then the plot number you're referring to. In this case, we'll just go ahead and say 1. Then we'll go ahead and plot something on that cell. We'll say XY, and we'll go ahead and specify that it's the color red with the string R as a third argument. And again, don't worry too much about fully understanding this, because once we get to the object-oriented method, a lot of this is going to make way more sense. But I just want to show you what's possible for now. And let's go ahead and say another plt.subplot. We specify 1 row by 2 columns, and the third argument is the plot number. Now we're going to edit the second plot, and we'll say plt.plot. We'll go ahead and do y versus x, and specify b for blue as a string here. Let's go ahead and run this and see what we get. Okay, so now we have 2 subplots here. That's creating multiple plots on the same canvas. Now what we're going to do is, after we've seen the very basics of creating a plot, we're going to break this all down with a more formal introduction to Matplotlib's object-oriented API method. And this means we're going to instantiate figure objects and then call methods or attributes from that object. And that's going to be a much better way of actually using Matplotlib. So the basics for now are just using plt.plot and then putting in your data. Or plt.subplot, specifying the number of rows and columns, and then the figure you're working on, and then using plt.plot. Let's go ahead and switch gears to the object-oriented method. And this is going to be much better. The main idea in using the more formal object-oriented method is to create figure objects and then just call methods off of this. So let me go ahead and show you what I mean by that. I'm going to go ahead and say fig is equal to plt.figure. And I'm going to go ahead and close the parentheses there. Now, if I just run that cell, notice I have a figure object has been created. This figure object, you can think of it as just kind of this imaginary blank canvas, and we can add a set of axes to this canvas. So in the same cell, I'm going to say axis is equal to fig.add underscore axes, and I'm going to add a set of axes. And the way you can add a set of axes is by passing in a list. And the list takes in 4 arguments: a left, bottom, width, and height argument that range from 0 to 1. Basically the percent of that blank canvas you want to go ahead and take. Let me go ahead and show you an example. And again, I'm kind of going to be showing you a lot of stuff that won't make sense at first, but everything will make sense at the end as you see repeated examples and you break it down further. So I'm just typing in some numbers here. This is going to be the left of the axes. This is going to be the bottom of the axes. And this is going to be the width and the height of the axes, 0.8. Let me go ahead and run this on the cell. And now notice what I get here. Now I have a blank set of axes. So I said plt.figure, created a figure object, and then off of that figure object, I called the method add a set of axes and passed in a list of where I actually want the axes to be placed. Next, what I'm going to do is actually plot on that set of axes. And this is going to feel familiar to what we just did earlier. You're going to say axes.plot, and let's go ahead and plot x and y on that set of axes, and then do Shift Enter. And now you can see we've basically come up with the same plot we did earlier, except using an object-oriented method. So if I scroll back up here, this was the plot we did earlier, where we just said plt.plot, but now using this sort of object-oriented method, we're going to have a lot more control over this. It's a little more involved as far as the steps we need to take, but it's definitely worth it. So we've created a figure, we called the figure method add axes on this, passed in a list of axes, and then plotted on that set of axes. If we want to continue by putting X labels, Y labels, and titles, we can go ahead and do that on that set of axes. We can say set underscore X label. It's a little different from the PLT, which is just X label. When you're working with this axes object, you're going to have to say set underscore. And now we can go ahead and pass in the string X label. And you're going to do the same thing for Y labels. Whoops. ylabel. And let's go ahead and do the same thing for a title. Set underscore title. Now if we run this, we should see our new labels, X label, Y label, and set title. Let's go ahead and continue this idea of object-oriented programming with Matplotlib by putting in two sets of figures on one canvas. And this will start to make sense as far as what this list is referencing. I'm going to go ahead and scroll down to a new cell. I'm going to zoom in a little bit just so we can get a very clear picture of what we're actually doing here. I'm going to say fig is equal to plt.figure. So I'm creating that figure object. So there's my figure object. I'm going to say axes1 is equal to fig.addAxes. I'm going to go ahead and set main axes. They will be 0, 0.1, 0.1, and then 0.8, 0.8. And again, this is the left, the bottom, and then the width and height of that set of axes. And then I'm going to add another set of axes. Call them axes2. I'm going to say fig.add_axes. And then what I'm going to go ahead and do is basically put an insert axes. I'm going to say the bottom of this set of axes starts 20% from the left, 50% from the bottom. So excuse me here. I'm talking about basically this bottom corner of the axes, this left and the bottom. So 20% in from the left, 50% up from the bottom. And then we will say it takes up 40% of the canvas size and width and 30% of the canvas size and height. So all these values here must be between 0 and 1. Let's go ahead and run this and note what we get out. We get out this basically insert set of axes. And hopefully now you can begin to see what these values actually correspond to. What I want you to do now is go ahead and pause the video and play around with these numbers. Make sure they're all either between 0 and 1 and see how they correlate with this set of axes. Go ahead and just play around with axes 2 and move it around. For instance, try to get this set of axes 2 over here at this bottom corner. Go ahead and pause the video, see if you can move this insert over to the bottom corner. Alright, I'm going to see if I can do that now. So if I want this at the bottom corner, I probably want to say that it goes left, bottom, width, and height. So I will try shifting it down by making this basically just 0. So let's go ahead and say 0.1 here. Start at 0.15, just a little off the bottom of this insert here, or of axis 1. We'll go ahead and run this. And there I was able to move it more towards the bottom. Remember, this second one's the bottom. And now we want to move it more towards the right, which means from the left, I'll want it to percent-wise move this bottom corner more over from the left. Let's go ahead and set this as 8. And now it looks like shifted it a little too much, so let's go ahead and shift it back to maybe 0.5. And there we can see we have it now in the bottom. All right, go ahead and play around with that. If these figures or these numbers are still a little unclear, remember they're basically just denoting the left, bottom, and the width and height from range 0 to 1 in relation to the blank canvas. I'm going to go ahead and reset these to what we had them at originally, 0.2 and 0.5. So we have our little insert there. And then what I'm going to do is go ahead and plot on these axes. So I'm going to say axes 1 dot plot, and I will say x comma y. And then I will say axes 2 dot plot, and we'll go ahead and say y comma x. And let's go ahead and run this. And here I can see now I have my little insert and my outer plot. And then I can keep adding stuff on each set of axes. So if I want my insert to have a title, for instance, that's axes 2, I can say axes 2 dot set title, and we'll go ahead and say insert. Well, let's go ahead and make it very clear. We'll say smaller plot. And then on axes 1, let's go ahead and set a title. And we will set this title as larger plot. Let's go ahead and run that. So notice what happened here. I actually got an error because I didn't actually see smaller plot because I forgot to put a 2 here. Let's run this one more time. Okay, now we are getting what we're supposed to get. We have larger plot and smaller plot. And basically, that's the idea behind object-oriented programming with Matplotlib. You create a figure, and that's essentially just an empty canvas. So let me go ahead and show that one more time just by putting this in a cell by itself. We create this empty figure, there's nothing to show, and then you add a set of axes to it by saying axes, whatever, 1 or 2, etc., equals fig dot add underscore axes, and you pass in this list that goes from left, bottom, and then the width and the height in relation to this empty canvas. So if we run this, then we have our empty set of axes, and then you can plot off those axes. You can say axes 1 dot plot, and then x comma y. All right, this is the sort of methodology we're going to be working with for Matplotlib. As far as the very basic way of working with Matplotlib, which is the functional method, you can just say plt.plot or plt.subplot. But we're going to learn how to create subplots using this object-oriented method, which is going to be a lot more efficient and grant us a lot more control. Okay, go ahead and review this section of the Matplotlib Concepts Lecture Notebook. There's a lot more notes and a lot more comments in the notebook in case any of this confused you, but hopefully by now you have a full understanding of basically these lines of code right here. If you understand what's going on in this cell, then you're pretty much good to go. We just create a figure, we add an axis to that figure, you define the location of that set of axes with this list, and then you can plot on that set of axes. You can set the title, set the X label, Y label, etc. Alright, thanks everyone, and I will see you at the next lecture where we're going to continue this discussion off of this same Jupyter notebook. Thanks, and I'll see you at the next lecture.